So today we'll be going over a technique in solving radical equations, and today we'll specifically go over substitution. So by what I mean by substitution is replacing a certain, like for example, a polynomial or expression like x squared plus x plus 1 as a single variable. And this is a technique not only for solving radical equations, but in algebra and other stuff in general, because it's good for simplifying equations so that calculations become much easier. But here we'll just specifically look at for solving radical equations. So we will solve a problem. So it's difficult to just say it in words. So I'll make it clear by solving some problems with you guys. So, and feel free to always pause the video and try it out and finish the problem on your own when you feel like, oh, you know what to do after that step. So the first problem is to solve x squared minus x is equal to 2 times the square root of x squared minus x plus 3. So we have a radical equation. So your the first instinct of many people would be to square both sides, because that's simple. It just gets rid of this radical. But this will become a quartic, and we don't want a quartic because, I mean, you might be able to factorize it easily, but if you're good at algebra, but it's not that elegant. It's not that easy to solve either. So we want to substitute in a variable so that it becomes an easier expression. So and yeah, also, like, the point of radicals is to always get rid of the radical, because radicals are difficult to deal with, and it's always nicer to have them gone. So we want to square both sides, but we want the expression here to be simpler, like a linear expression. So we want to make these expressions simpler. But then we realize a pattern, because we realize this expression contains this part, and this expression contains this part as well. So they only differ by a constant, 3. So we might be able to substitute in a variable, and then this will be like, if this is y, if this entire thing is y, then this would be equal to y minus 3. So maybe we can try that. So we're going to put this entire thing as, so we're going to put this expression, not including the radical, as y, and we're going to put, and then this one, and then this expression would then be equal to y minus 3. So if we substitute it like this, we do get a linear expression here. And because if we put this as y, then it only decreases by a value of 3. So we found this similarity, and then we substituted so that this becomes simple. Or you can have this as y and then this as y plus 3, but I don't know, it doesn't matter, but all that matters is that you get a linear expression on this side, a simpler expression to square. So now that we substituted it like this, we get that y minus 3 equals 2 times the square root of y. If we square both sides, we get this. Oh, that's not x. That is not x. That is, what was it? Yeah, 6y plus 9. And then it's y squared minus 10y plus 9 equals 0. So this would be y minus 1 times y minus 9. So y is equal to 1, or y is equal to 9. So there we go. But we're not done, because we're not looking for y, we're looking for x. So we put x squared minus x plus 3 as y. So y is equal to x squared minus x. Okay, wait, I'll put that. Yeah, I'll put, no, yeah. Y equals x squared minus x plus 3, but y equals 1 or y equals 9. So, okay, I'll bring that up maybe, but, wait a sec. I'll just rearrange this. So we know that y is equal to x squared minus x plus 3. Oh, why is this lagging? X squared minus x plus 3. And we know that from our quadratic, y equals 1 or y equals 9. So x squared minus x plus 3 is equal to 1, or x squared minus x plus 3 is equal to 9. So x squared minus x minus 2 is equal to 0, and x squared minus x minus 6 is equal to 0. And these quadratics are pretty simple. I did go over how to factorize it here, but like I'll just go straight into it due to time constraints. So this would lead to, actually I'll just show you the entire thing, yeah, just to make things clearer. This will be x minus 2 times x minus 1 is equal to 0, and x minus 3, x minus 2 is equal to 0, so x equals 2, x equals 1, I'm not going to write it like that. X equals 2, x equals 1, 3, and 2, but like that's repeated, so that's it. So that is the solution. And don't forget to plug it back in to check if this makes the radicals negative or not, because like we can't square root a negative number. So we have to plug it back in and check if it makes it negative or not. And also we have to check if this part is going to be negative or not, because if we don't have a plus minus in front of here, like I said in the denesting radicals video, if it doesn't specify in front of the radical whether it's plus minus, then its entire value would be positive all the time. So we have to check if this is positive and this is non-negative. Oh no, this should be non-negative as well. So if we plug it back in, you can easily see that it is that it will be fine. So that was the first problem. And then we're gonna go over the second problem, which might be a bit easier, but it's a nicer problem, so I put it at the end. So the second problem states, solve for x if you have x plus 2 plus 3 times 2x minus 5 minus square root of x minus 2 plus 2x plus 5. Oh, 2x minus 5, sorry. So we have, this time it's a bit messier because they want us to evaluate this, so which means they want us to find the value of this, which means that this would lead to a constant, regardless of what value x is. So we want to kind of, I guess some things will cancel out, but we shouldn't be aiming to cancel out x, but firstly we should be aiming to simplify each radical, and we can do that by substitution, because firstly we realize that we see a square root of 2x minus 5 here and a square root of 2x minus 5 here. So what if we substitute y as the square root of 2x minus 5? So what if we put y as square root of 2x minus 5? And this is actually a really easy and smart technique when you solve radical equations, when you simplify radical equations, because if you set a whole radical expression, like including the radical itself, as a single variable, then you will substitute it in and you will automatically get rid of the radical, which is pretty nice. But then it comes with a cost. It comes with a cost because when you put, now we have to put x, now we have to put the other expressions. Now we have to put the other expressions in terms of x, in terms of y. But in this problem, it will actually be pretty nice. So if we look here, so if we try to put it in terms of, if we want to put x in terms of y, so that we can substitute it into here, then if we square both sides, it will be y squared equals 2x minus 5, and therefore y squared plus 5 over 2 is equal to x. So we'll just substitute this in here, and it's a square, and it's a quadratic, but that's much nicer than having a radical here. So with the cost of getting rid of this, we got a quadratic, but actually having a quadratic might be ideal because that means if we have a quadratic, it might be the square of an expression, and that would be really nice, but it would be really coincidental. But yeah, we'll have to see what happens. So if we solve it, so we substitute all those values in. So this would be y squared plus 5 over 2 plus 2 plus 3y minus y squared plus 5 over 2 minus 2 plus y. And then if we bring them all to the numerator, this will be y squared plus 6y plus 9 over 2. This will be y squared plus 2y plus 1 over 2. And then as we wanted it to, we realized that this quadratic actually becomes the square of a linear expression. So this is equal to y plus 3 squared. This is equal to y plus 1 squared. So this would just be y plus 3. Oh, it's just y. So this is y plus 3 squared. So if we square root it, it just becomes y plus 3 over root 2 minus y plus 1 over root 2. And then the y's cancel out. So we don't have to even plug x back in. Like we substituted in y, and it just canceled out itself, which is really, really nice. So we just get 2 over root 2, which is equal to root 2. And that is our answer. So that was a really nice problem. Like I found it on Google while just searching for some physics identity that I was looking for. And I found this by pure chance. And I was really fascinated by, yeah, though it's a really simple problem, like, and though it's a really simple problem, it's really nice how someone can come up with this kind of expression, this kind of problem, so that it ends so elegantly. Yeah, this was a really nice problem, but the main takeaway would be that always put this as another technique of substitution instead of what we did in the first problem where we found a similarity and then we were trying to simplify the expression so that when we square it, it doesn't become that complicated. Here we just substituted the entire radical as a single variable so that we're denesting it. So yeah, and then I mean, you can modify the problem and then try another problem again. Like you can make it so that it doesn't become the square of an expression but something else, and then you can substitute something else in again, and then try to do something again. So yeah, it's radical equations. When you do them for the first time, they're pretty annoying because sometimes you don't know what to do, and they're annoying to deal with. But once you get the hang of how to get rid of them, then it becomes very nice. So yeah, I hope you enjoyed that video, and see you in my other algebra, number theory, combinatorics, and geometry videos.